Yeah, good morning everyone. Today in this class we will discuss about the next topic of your unit 5 terms which we are using in that gear. So in that gear which terms we are using and in the depth deeply we will discuss. Okay. In the last class we will discuss the names. Okay. In that last class we are already discussed about this structure and names. So what will happen in that names we will discuss here. Okay, terms used in a gear. First is pitch circle, pitch diameter, pitch point, pitch surface, pressure angle or angle of obliquity, addendum, dedendum circle, circular pitch. So these are the 10 different terms. Okay, another also there, total 14 terms are there. In that pitch circle, what will be happen, you know very well the center line of the pitch circle. So the main is in that main some points are in the terms, main terms are there. That main terms will be useful to solve the problem while you are doing the problem. So here I am giving the main terms definitions. So the first is circular pitch. What is circular pitch? It is a distance between the circumference of the pitch from the point on one tooth. Means here you can see one tooth is there. Circular pitch is mean a circumference of the pitch circle to the tooth circumference to the point of the tooth, another tooth. So this is called as circular pitch. Circular pitch, it means the first tooth point of the pitch circle to the another tooth point of the tooth surface, that is called as circular pitch. Okay, and the circular pitch denoted by the PC is equal to pi d by t. D is the diameter of the pitch circle and T is the number of teeth on the wheel. How much the number of teeth will be there? The total number of the teeth we have to consider in that circular pitch. Note, if D1 and D2 are the diameter of the two mesh gear, means the two other gears are meshed to each other, that having a two different diameters will be there. Because of if it is same diameter, it will not be meshed. Okay, D1 and D2 are the two different diameters are there of the gear are meshed to each other. At the time the two different T will be there, that is called T1 and T2 respectively. Here you can see, here using PC is equal to one gear and another gear pi d1 by t1, pi d2 by t2. Pi will cancel, then d1 by t1 is equal to d2 by t2, and reciprocating these values and we will get the ratio t2 by t1 is equal to d2 by d1. That is called as the ratio of the teeth is equal to the diameter of the teeth on the two gears. Next is diametral pitch or diameter pitch. Diametral pitch, it means the ratio of a number of teeth, how many teeth are there on the gear, that ratio, and to the circular diameter in millimeter, pitch circular diameter in millimeter. The ratio of the number of the teeth to the pitch circular pitch circle of the diameter, that is the ratio between these 2 points. The ratio will be generated, the ratio of the number of the teeth to the pitch circle diameter in millimeter, that is called as diametral pitch. And here we denote as PD. PD is equal to pi by d. Okay, or is equal to pi t by d, or is equal to pi by PC we can return. Pi t is equal to number of teeth, as you know d is the pitch circle diameter. Okay, this is your diametral pitch. Where you are seeing this diametral pitch? The diametral pitch circle, or here you can see the diameter pitch. Okay. Okay. The next is module. It is the ratio of the pitch circle diameter in millimeter to the number of the teeth. It is a reverse to one. In that reverse, if pitch circle diameter, the ratio of the pitch circle diameter to the number of the teeth. The ratio of the pitch circle diameter to the number of the teeth, that is called as module. And m is equal to d by t. I just now told you reverse, it is the reverse. You can see PD is equal to T by D is there. Here m is equal to D by T is there. If it is in reverse order, that is called as module. If it is in forward order, that is called as diametral pitch. The recommendation series will be there for the module is there. Here note the Indian standard series are there. Recommendation, this is 1, 1.25, 1.5 and module 1, 1.25, 1.37, like this the standard series of the module will be there. Okay. The next is clearance. What is clearance? Clearance means it is a radial distance from top of the tooth to the bottom of the tooth. That is called clearance. Top of the tooth to the bottom of the tooth are meshed to each other by the to another outer surface of the gear, that is called as clearance. Okay. Or we can say the clearance circle also. Tool depth. What is called as tool depth? In that tool depth, it is a radial distance between the addendum and dedendum circle. It is called as tool depth. You can see here tool depth. In the previous class, tool depth is called as addendum circle this one and dedendum circle this one. Between these two points, tool depth will be there total. The ratio of these 2 points, tool depth will be there. Radial distance between them. Okay. Then 15 is working depth, tooth space, face of the tooth and tool thickness, backlash, flank of the tooth, face width, profile, how the profile will be there of the tooth, path of contact, arc of contact and filter radius, length of path of contact. These are another terms are there which we are using in that gear. Okay. You can see here the different names also there. I already told you. Okay. So the next very important topic regarding your derivation, the question will ask exactly about this topic. That this topic name is condition for constant velocity ratio of tooth wheel law of gearing. Okay. Explain about the conditional statement or conditional statement of velocity of tooth wheel law of gearing. Okay. So first in this case we are considering the two different teeth of the gear. What we are considering here? The two different teeth of the gear. One is gear. One wheel is called as pinion and another wheel is called a thick line curve. Okay. First one wheel is called as pinion and another wheel as thick line curve. Okay. Or else we can drag also. The first here we are considering the let Q is a point of contact between the pinion or thick line curve. Okay. And T, what is T? T is the point from T to T is a point that is called as a common tangent when the pinion is acting on the thick line curve. Okay. And Mn is the common normal curve at a point of contact between these two wheel. Wheel A is a pinion, wheel B is a thick line curve. You can see here the diagram also I will give you. Wait for a while a minute. This is your diagram. Okay. This one wheel is called as rack or pinion, and another wheel is called as thick line curve. Here the curve will be there. Okay. What happened in that? We are just doing that only. From the center of O1 and O2, drawn from O to M, O1M and O to M are perpendicular to MN. Here you can see. Okay, this is the center O1 to M1 and O1 to, this is the center of them, of these 2 point wheel, that is O1 M1, and this is that point O2 M2. Okay, this is your common tangent. Mn is a normal curve of this point, and this is your point of contact. Okay, O2 to N1, O2 to N, and O1 to M. These are the 2 points of the line. And here we are seeing the little concentration, means the motion will be seen here, and where from first wheel is moving, and this is power transmission or motion will be transmission to the second wheel. So here we can see first will be moved like this, the second will be moved in that rotatory motion, that is called as law of gearing. Here you can see the derivation part also similar. The tangent, from the tangent O1 you can see the O1 MP about this point, O1 MP, O1 MP. What you are noticing? The triangle will be one of the right angle triangle will be shaped, that is M point, the 90 degree will be there. So like this O2 NP and having a 90 degree, that is also a angle will be there, right angle triangle will be there. So O2N by O1M is equal to O2P by O1B. We can write. The first formula is this for this point. Okay. So what we are noticing here, so again I am telling to you, I already told you about the T to T is a common tangent, Mn is a common normal, and Q is a point of contact where the curve is intersecting to each other, and at that point O1 to M1 and O2 to N2, at that we have to draw the line, and that is a perpendicular to Mn, and M at the point of M or N the 90 degree will be there. At this point we are seeing the little concentration will be there with that point of contact. At this point of contact Q, the wheel A will be rotated, and that motion will be transferred to the wheel B. Okay. Now we have to suppose the velocity V1 and V2 are the two velocity at this point of contact Q. Okay. If the teeth are remain contact while moving, the teeth are remain constant, that is called as component of the velocity along the common normal, and it must be equal to the Mn. Okay. So V1 cos alpha is equal to V2 cos beta. Okay. We know that V1 is equal to omega into O1Q. With the help of right angle triangle, just now I told you V1 is equal to omega 1 into O1Q. V2 is equal to omega 1 into O2Q. You know that omega is the angular velocity. Okay. Just we are substituting the value V1 and V2. Okay. Then after that where the cos alpha is equal to O1 by M1 by O1 M1 by O1Q. Cos theta is equal to adjacent by hypotenuse. So by the helping of right angle triangle we are finding the cos alpha O1 M by O1Q, cos beta O2N by O2Q. Thus we are substituting the value and cancel the O1Q1 O1Q1 O2Q2, O2Q2. Omega 1 is equal to O1 M1, omega 2 is equal to O2 N. Just cross multiplication of this, we will get that the O1 by O2 is equal to O1 M1 by O2 N. That is our equation 1 of the your velocity ratio. Then next, this is the same page, is all came here. No need to confuse. This is already we discussed. In that we are discuss the equation 1, and then we have to discuss the another part of this derivation. Okay, this is the second part. Here in that second part, the diagram is shown to you to understand the law of gearing, how the law of gearing is acting. First wheel is your rotating wheel, and that is a pinion. Second wheel is your line curve. Here the meeting point will be there. This is your tangent, common tangent. This is your normal curved surface. Okay. After the draw the normal curved surface, we are seeing here PMO1 is a making as a right angle triangle. O and P is a making as a another triangle. Okay. Also for from similar triangle O1 MP and O2 NP, we are finding some values. Okay. O2 N by O1 M is equal to O2 P by O1 P. Equation 2. Then combining equation 1 and 2, due to O2 N by O1 M is there in equation 1. You can see again here O1 M by O2 N. It is in the form of O1 M by O2 N. Just we have to reciprocate this value W1 by W1 by W22 in terms of W2 to W1, means omega 2 to omega 1 is equal to O2 N by O1 M we will get if we are reciprocating. Here we have to reciprocate due to the second equation in terms of O2 M by O2 N by O2 N by O1 M. Okay. Next O2 P by O1 P. Here the second equation, here the value of O2 P by O1 P is there. Then we are seeing here the angular velocity of the ratio is inversely proportional to the ratio of the distance of point. Means how much the angular velocity will be there between these two wheels, that is inversely proportional to the ratio of the distance of the point P from center O1 to O2. And the common normal surface at a point of contact of Q will be there at a point of P, and which is divide the two parts inversely. Okay. The next, the 2 points are there, very important. The pitch point, first is pitch point. In order to having a constant angular velocity, if we are having to find the constant angular velocity between two wheels, that P must be a fixed point. The P point must be at a fixed point, and that P is called as pitch point. Pitch point should be fixed point, and that point we will find the constant angular velocity. Okay. The common again we can in different way we can see this is, that's why we are made star mark for this point. That is the definition of the pitch point. The common normal line at a point of P, if between gear is passing through the point P, is called as pitch point. Common normal line at the point of contact between the gear and the fixed point is called pitch line or pitch point. Okay. Next is fundamental condition. Fundamental condition must be satisfied while we are designing the gear. Okay. So that is a fundamental condition of the derivation of the formula of law of gearing will be there. That is called as omega 1 by omega 2 is equal to O2P by O1P is equal to D2 by D1 is equal to T2 by D1. This is the final law of gearing formula. While you are solving the problem, you have to use this. Okay. Thank you very much for watching my video. Make sure to give me the attendance while completing of this video. Okay.